Thank you. So we'll be solving a numerical on what is called as statically indeterminate structures. So the name says statically indeterminate structures or statically indeterminate. Now in this problems, so for this we can take an example of a load of 50 kilonewton acting over three different materials of different stiffness. This is copper, this is steel, this is steel. So steel on either sides. So Young's modulus of steel is 200 GPa. So higher stiffness. Young's modulus of copper is 100 GPa, slightly lower stiffness. And the length of this are from here to here is 2 meters. From here to here is 1.5 meter. Okay. Now we'll not be able to answer this question just by writing an equation like this. So load taken by steel plus load taken by aluminium plus load taken by steel is equal to 50 kilonewton. I can't answer this question just by this equation because there are two unknowns here. Now this can be written as 2PS plus PIL. Sorry, copper. So 2PS by PC is equal to 50 kilonewton. So I can't solve this problem. So statically, that means if you feel that it's not going to deform due to load, then you can't solve this because there's a single equation. So we assume that the structure is in such a way that the loads will actually deform this by equal amount. So when you actually place two lower stiffness material on the other side symmetrically and one higher stiffness material on the center, they will actually deform they will deform equally because this load will come down like this. So we assume that this deformation dl is same for all of this. So I can say that deformation of steel is equal to deformation of copper. So or I can write this as PL by AE of steel is equal to PL by AE of copper. So this is for copper, this and all this is for steel. So then we can say PS in terms of these known numbers which are given in the problem. So then we can solve this. So this would become a number here in the numerator, this would become a number in the denominator, and therefore you can express PS in terms of PC and then substitute this equation 3. You can call this as equation 1. You can call this as an equation 1. You can call this equation as 2. You can call this, finally you get this value of PS in terms of PC. You substitute this in equation 1 back into this equation 1. Then everything is written in terms of PC. Then you find out the value of load in copper. Then you can substitute this back in equation 1. Then you can find the load in steel. So these types of problems are called as statically indeterminate. When you assume that they will not deform, so you can't solve it. So only when you assume that they actually deform by equal amount, you get two simultaneous equations to solve. Basically not two simultaneous, but basically two equations to solve. Guys, I think you know that there are two unknowns here, load in steel and load in copper. There are two unknowns. You can't solve it by single equation. If there are two unknowns, you need two equations to solve. So basically we are getting two equations here to solve it. So when the number of unknowns are more than the static equations that you can make, it is one static equation that you can make, then these are called as statically indeterminate. Then you need one more equation like this to actually solve this. numerical. So let us start solving this numerical by using this concept here. So let us start with this value because you need to substitute this value to this. So anyway, I've already written here 2 PS plus PC is equal to 50 kilonewton. So let us start with this value now, these values here. So here, I will substitute these values here. Load in steel is not known to me. So let me call it as PS. Multiplied by length of steel is how much? 2 meters. So let us call it as 2000 millimeter because we are expressing everything in terms of MPa, which is actually Newton per mm square. Okay. So it is left to you. If you want to express this in 2 meters also, it's okay. Finally, you should express all others in terms of Newton per meter square. Okay. So let me do this. So length is 2 meters. Area. So again, it becomes difficult for us here. If you don't want to add bigger numbers here, then here for this area you will get in terms of meter square very less value, which is actually 10 to the power of minus something. So you'll have to compromise somewhere. So let us put this as 2000 mm itself. It will be easy. Then area of steel is pi r square. So pi into r. So each of these rods are 20 mm. So let us assume that each of these rods are 20 mm. All of this the steel, copper, and all of these rods are 20 mm. So 20 mm is the diameter, 10 mm is the radius. So pi r square is the area. Young's modulus of steel is 200 GPa. So 200 GPa. 200 GPa is what? 200 into 10 to the power of 3 Newton per mm square. So that is the value. So this is equal to what value? So PC into LC, which is 1500 mm, divided by pi into 10 to the power of pi r square. So this is 100 into 10 to the power of 3 Newton per mm square. So here, if you say this directly, you can cancel a lot of things. You can cancel this and this. Okay. You can cancel this with this too. You can cancel this and this with 2. So you can say, so PS is equal to, so PC, here you got 1500 mm, 1500, okay, now forget about the units because we have taken care of the units here. So 1500 which was here, let us put this back here, and then divide by 2000 here. So okay, this I can cancel, this I can make it as 1000. So 1000. So as I said, it almost came to 1.5 itself. Okay, so load taken by steel is 1.5 of PC. 1.5 of PC I got here. Once I got here, we can substitute back into this equation 1. So this is equation 3. You call this is equation 3. You can substitute back into this equation 1. Okay. So here, so PS is 1.5 PC. So 2 into 1.5 PC plus PC, which is actually equal to 50 kilonewton. 50 kilonewton is 50,000 newtons. Or otherwise, you can express this in terms of, okay, it's left to you, whatever. So what is this over here? So much is this? 4 PC. So 4 PC is 50,000 newtons. So PC is equal to 12,500 newtons. Or 12.5 kilonewton. So once you have got this PC, then you can say here, so you can substitute back here. So substitute back into this equation 1. This value again in 1. Again in 1, you can put this. So PC is equal to PC is equal to 12.5. So 2 PS plus PC, which is equal to 12.5 kilonewton, is equal to 50 kilonewton here. So how much is PS now? 50 minus 12.5, 37.5. 37.5 kilonewton minus, sorry, divide by 2. What is the answer? 18.75 kilonewton. Guys, which means that here the load taken by steel rods are 18.75 kilonewtons. So out of this 50 kilonewton, 18.75 kilonewton, 18.75 kilonewton is taken by steel. What is the load taken by copper? That is actually 12.5 kilonewton. This is purely because of the stiffness. Young's modulus. Young's modulus is 2 times. For the same, now to actually push this by the same amount. Here this resist more. If I am strong, you can't push me easily. You need a lot of load to push me down. Okay, so pushing the steel by same amount of copper, steel will take more load, copper will take less load. You can see here 18.75. This is actually 12.5. Okay, so like this you can find out. Maybe this numerical will ask you a little bit extra. They will ask you what is the stress in steel and stress in copper. So can you find it? So you can find it because you know already the load in steel and load in copper. So if you want stress in steel, if you want stress in copper, so load PS divided by area of S. So load in copper divided by area of copper. Okay. So load in steel is 18.75, 18,750 divided by AS, which is pi r square. So pi into 10 mm square. So what is the answer, guys, here? 59.8. Here you get this as 59.8 Newton per mm square. Here you get this as how much?
39.4.
Huh?
39.4.
Here you get it as 39.4 Newton per mm square. Okay. I think you got the same answer. These two guys, okay, also. I think these two guys, this guy and this guy, got it in around 4.5 minutes. Maybe I wish maybe there was some confusion there. You also said the same thing? Okay. I think they solved it a little bit extra time they took, maybe 1 minute. So what's still sitting in the last bench, they have done it. Maybe if they sit in the first bench, they would have definitely done it still faster. Okay, I wish you sit in the first benches on the next class. So in this way, can I write the names? Because I'll take a snap of this and actually post it when you graduate. That's on the graduation day, I will actually put this photograph. Oh, now what's the first guy? That's. That's Ajab Bachcha. Bhargav. Okay, I got these two peoples and others, I don't know. Okay, I could not measure the time. Okay. Last bencher, huh?
Last benches.
Okay. So I've also taken a photograph like this also, I'll take now. So everybody should see. Okay, it's also being recorded, huh? Okay.